I'd like to look at the next problem, and here it is. It says, use five rectangles to estimate the area under the curve from 0 to 10. The graph is given. Let me just adjust this so you can see it better. And adjustments, just put it right on the mark. Right there. Perfect. A bit above. That's because we shifted the graph. It landed on a piece that should not have landed. There we go. So, A, if I want to use L sub 5, well, L sub 5, I'm looking at the rectangles. Delta x in all of these cases is end minus beginning divided by 5 is 2 units. These are the 5 rectangles that I'm looking at. Well, let's see. If I go for L sub 5, the left-hand approximation, I go to the first interval, which is 2, and wouldn't you take f of 0? Right? This is y equal f of x. Wouldn't you say this is the height? And you create such a rectangle. Isn't the height 7 in this case? When you look at the second interval, don't you take this left endpoint to be the height? Isn't that f of 2? And what's f of 2? What do you think that value is? We're not going to disagree. Between 6 and 7. I'm going to say 6.8. And I look at the third interval. That's 2. The 2 is already there. And the height is going to be, so I'm finding this. What's that height? That looks like exactly a 6. That's f of 3. Plus, when I look, I'm sorry, that's f of 4. So it was 0, 2, and 4. Plus, when I look at this interval, that looks like a 5.1. That's f of 8. And of course, f of 10, when I look at the last, that's f of 6. Okay, I should have did that first. I'm trying to get a point across. And f of 8 is about 3.5. So I should have 5 of those. The left-hand approximation is roughly 13, 6.8 plus 5.1, 13.9, no, 11.9, and 3.5, that is 14, 8, 28.4. So the area is roughly 14.2. That's the left-hand approximation. The right-hand approximation, that's a 2 into. Now think about it. Here's my interval. I'm trying to get this point across. We're running from 0 to 4. The goal is for us to figure this out without visually looking at it. If I say take the left-hand approximation, when you look at each interval, don't you take the left endpoints? That's an 8. Right? I don't need the graph of that. Do you see it's f of 0, f of 2, f of 4, f of 6, f of 8? What do you think is going to happen if I'm going to go for the right endpoint in each of those? Isn't that going to be f of 2, f of 4, f of 6, f of 8, and f of 10? Don't you drop the first, because on the first interval, you are going to take this to be the height. On the second interval, you're going to take this to be the height. Third interval, you're going to take this to be the height. Fourth interval, you're going to take this to be the height. And the fifth interval, you're going to take this to be the height. So in this case, this is an overestimate. because you're adding more area than you should, and this is going to be an underestimate. And how does that work? Well, we know already what those are. F of 2 plus F of 4 plus F of 6 plus F of 8 plus F of 10. But wait a minute. We did most of this work already. F of 2 is right there. A 6 for F of 4. A 5.1 for F of 6. A 3.5 for F of 8. F of 10 is the only value I need to find, and that looks like a 1. And do you notice in this case, I'll get this to be 2 times. Let's see what this is. 7. 6.8 plus 5.1, 13.9 plus 7 plus 5.1, that is 10, 10, 16, that's 26, that is 13. So far we have those two. And I'm going to do one more approximation, which is what they asked me to do, and that is m sub 5. If I go for m sub 5, well, let's see. That is the length of 2 for each of those, but isn't that going to be f of the midpoint, f of 1, and f of 3? Do you notice you add delta x, you get the next one? And here, between 4 and 6, isn't that f of 5? And between 6 and 8, isn't that f of 7? And f of 9? And that's pretty much it. And what are those values? That is 2 times, well, here I need to evaluate them. F of 1 looks like a 7. F of 3, that looks like a 6.5. A bit above, a bit below, we're not going to disagree. F of 5, if I look at 5, that is about 5.8. If I look at f of 7, there's 7. That's about 4.5. And if I look at f of 9, oops, f of 9, that looks like a 2.5, 2.4, whatever that is. And in this case, I'll say that is twice. You know what? There it is. That would be twice. And what is that? 4.5, that's a 7. And 7 is 14. And 13, 14.3. That is 28.3. So that is 14. 14.15, which is normally about the average of those two, about. But there it is. So let's make this a general case. Given f of x over an interval between x equal a, and let's say a is not at 0. If I want to find this area, if I call this x sub 0, if I call this x sub 1, if I call this x sub 2, if I call this x sub 3, if I call this x sub n minus 1, and if I call this x sub n. So when I take delta x is always end minus beginning divided by how many intervals do you want, and that's always specified. X sub I, to find the x's, normally we say, well, it's simply I times delta x, right? If you look at this, if you want to find this x, right, take 3 times the right side. If I want this, 3 times delta x. Do you see that? 3 times 2 is 6. That's how it works. But if you start at 0, that's fine. If you don't, all what you have to do is add the starting point. And that tells you what the x's are. Now, if I look at the right-hand approximation, that's delta x times right-hand approximation. If you look at this interval specifically, don't you start with f of x sub 1, then f of x sub 2, and you will include the last because that's the right hand of each interval. If you do the left, when you look at the first interval, don't you take the left hand point don't you take f of x sub 0 plus f of x sub 1 plus, when you get to the last interval, don't you take the left endpoint so you never reach the last point on the graph? And if you go for the midpoint, you will say delta x times f of x sub 1 bar plus f of x sub 2 bar plus f of x sub n bar. What does bar mean? Take the midpoint of those. So to find the ith term, take x sub I plus 1 minus x sub I and divide them by 2. Average those. And area is approximately the right hand or the left or the midpoint, depending on how that works. Area, we're going to stick with the right endpoint. And the right endpoint, isn't that delta x times f of x sub 1 plus f of x sub 2 plus f of x sub 3 plus f of x sub n? Can't I say the sum from I equal 1 to n of f of x sub I times delta x, where delta x is b minus a over n and x sub I is a plus I times delta x. And this area is roughly the right-hand approximation. And if I take the limit as n approaches infinity, did you notice what happened as I added more rectangles when I went from 4 to 8? It became more accurate. If I'm able to fit an infinite amount of rectangles in there, then that would be the exact area. And that's what this is saying. That's what this definition is. I just derived it for you. Now, use this definition to express the area under the curve as a limit. Do not evaluate the limit. That's the next section. If I look at this problem, now I'm going to start this problem by running from 0 to 4. So that's the tradition. And then I'm going to shift that. I'm going to run that from 6 to 10. Same idea. Well, if I want to use this definition, this is what I need. I need delta x. Delta x is b minus a over n. So it's 4 over n. And x sub I, that's what I need. It's right there. In this case, x sub I, a is 0, so it doesn't come up. It is I times delta x. So it's 4i over n. And if I want to find an expression for the area, we're going to say area equal the limit as n approaches infinity of the series I equal 1 to n of f of x sub I of f of 4i over n times delta x, and delta x is 4 over n. So what would that be? I don't think we need that much space, but just in case. So area would be the limit as n approaches infinity of the series I equal 1 to n. If I take this, oops, and I put that in place of x, wouldn't that be 4i over n cubed plus the square root of 3 plus 4i over n, all multiplied by delta x, and there it is. How about this problem? Well, part B, delta x is b minus a over n. That is 4 over n. That didn't change. X sub I is the starting point plus I times delta x. So what is f of x sub I? Do the whole thing. That is 1 over x sub I is this mess. 6 plus 4i over n minus 2. So area is going to be the limit as n approaches infinity of the series I equal 1 to n of, if I simplify this, that's 1 over 4 plus 4i over n times delta x, and delta x is 4 over n. How do you find that expression? That's the next section. this is giving you the area. This is giving you an expression coming up with the area. Now I made those up. Let me see if they're going to work. And if I want to work backwards, let's see how that works. So I'm looking at this and I'm matching this with the limit as n approaches infinity of the series I equal 1 to n f of x sub I times delta x. Well, delta x obviously is right there. So delta x is b minus a over n, and that is 2 over n. That means b minus a is 2 units. X sub I is a plus I delta x, and isn't that this? So 1 plus I and delta x is 2 over n. Doesn't that make a equal 1? So out of this, I get a to be 1, and the length of the interval is 2 units. If I start at 1 and I run 2 units, wouldn't that be 3? So x is between 1 and 3. F of x is the square root of x. And that's what we're trying to find. We're trying to find the area under the radical between 1 and 3. That's what that's saying. And if I go for the second piece, same deal. I look for delta x first. That's an easy, oops. That's an easy target in this case. Delta x is right there, because it's always multiplied by the function, and this is obviously f of x sub I, and this is delta x. Well, delta x is b minus a over n. That is 4 over n, so it's a length of 4 units. X sub I is a plus I times delta x. Well, if I look at what they substituted in, I times 4 over n, that's delta x, that must be the a. So this graph starting at -1, but I move 4 units. So x is between -1 and 3, that's 4 units. And f of x, what do you substitute that in to get x cubed plus 2 of that? That's x cubed plus 2x. That must be the region you're trying to find the area under. And that's pretty much it for this section.